All right, everybody. I'm Dr. Gray. I'm going to be going over the second exam. And I'm going to work through all the problems on this exam and give a little bit of an explanation and periodically reference materials that we've seen before where you can find these answers. So let's kick things off. So this is your Chem 1341 exam. Questions number 1 through 25 correspond to the first bit of material, or that first module of material. And then questions number 26 through 50, those correspond to the most recent material. Now, I'm going to go question by question, so I'm going to zoom in a little bit here. So the first question reads, a substance with a uniform solution is best described as A, pure substance, B, a homogeneous mixture, C, a bivalent mixture, or D, a heterogeneous mixture. Now, this word solution right here should indicate that we're talking about a mixture. We've got multiple things in there. And so that's going to dismiss pure substance as a good answer option. So then when you see solution, you should kind of go through a thought process of, okay, I'm thinking solution, now I'm thinking of a mixture. And then the second word, or the preceding word there, uniform. Well, a uniform solution is going to be the same throughout. Well, I hate to use the word uniform in the definition for uniform, but it's going to be the exact same. The composition is going to be the exact same throughout that solution. In which case, our best answer for this question is B, homogeneous mixture or homogeneous mixture. Okay, so while I'm doing this, I'm also going to be filling out the key so that I can run this Scantron. So first question is B. Okay, second question. Which of the following elements does not exist as a monatomic or diatomic element? Okay, so your monatomic elements that are most frequently observed are going to be your noble gases, whereas your diatomics are, if you look at the periodic table, which I'll pull up the periodic table here, I always teach them as H. Broncliffe. That's a reference to my chemistry class that I took from Mrs. Jones in high school. But another way to look at these is to, I'm going to annotate here, these right here, NOFClBrI2, those seven elements are your diatomic elements. There's 7 of them, and they make a 7 on the periodic table. I hope you can see that as it's illuminated in blue there, or it's circled in blue. So if we can go back then, and this is a good one that if you have your periodic table, which I gave you a copy of that on your exam, that's a good place to reference. So does not exist as a monatomic or a diatomic element. Cl2 exists as a monatomic element, or Cl exists as a monatomic. He is a noble gas, exists as a monatomic. H2 or hydrogen exists as H2. F exists as F2, leaving behind only Te or tellurium as something that is not a good candidate to be a monatomic or a diatomic element. So that means that question number 2 has D as the correct answer. Okay, next up. Which separation technique is commonly used to separate colloids? Okay, so I'm going to pull up I'm going to pause. Now I'm ready to switch to the first PowerPoint of the semester, because remember, this is older material. Separation technique. Our major separation techniques were filtration, distillation, chromatography, and centrifugation. Now, chromatography is very effective for separating based on like affinity, attraction between a solution and its stationary phase. Distillation is great for separating based on boiling points. Filtration is great for separating solids from liquids. And centrifugation it separates based on, in large part, density, and is very effective for separating colloids. So if we can go back to our exam, right here. If we can go back to our exam, the best answer for this is centrifugation. So question number 3, the best answer for that is A, centrifugation. Okay, next up, which is an example of an intensive physical property? Okay, so our intensive physical properties. This is something that if you change the quantity, or an intensive property is something where if you change the quantity of that something, it will not change. It will remain unchanged. So one way that I always kind of think about that is if you have like a container that's filled with sand and you add more sand to it, does the mass of that sand increase? Yes, it does. Okay, now density is ultimately your best example of an intensive physical property, because density, no matter how much of that you have, the density of that substance or of a substance is going to be unchanged. Toxicity, on the other hand, if you think about toxicity, like water has a toxicity level. If you just, if somebody drinks too much deionized water, that could be fatal. If you drink a small thimbleful of water, of deionized water, that's not going to be fatal. So the amount of it is going to have an impact on its toxicity. So our best answer for number 4 is B, density. Question number 5, which of the following is the correct explanation of an intensive property? So a chemical property that is related to the amount of a substance, a chemical property that is not related to the amount of a substance, a physical property that is related, and a physical property that is not related to the amount of a substance. Well, when we talk about intensive and extensive properties, we're talking about physical properties. So that is going to eliminate A and B as good answer options. And keep in mind that an intensive property relates or does not relate to the amount. Therefore, our best answer for question number 5 is D, a physical property that is not related to the amount of a substance. Okay, an ice cube melts, or an ice cube, A, melts by absorbing heat from its surroundings, B, melts by releasing heat to its surroundings, C, melts by absorbing coolness from its surroundings, and A, cooling air molecules after heating by ice. Okay, so do air molecules get cooled by ice heating them? No, so D isn't a good answer option. So melt by absorbing heat from its surroundings is really the best answer option, because that ice cube is going to it's going to cool the air surrounding it, but it's going to be heated by its surroundings. So it melts by absorbing heat from its surroundings. A is the best answer option. Okay, number 7. Precision can be assessed after a single trial. So this question is really getting after precision and accuracy. And so I always like to think about examples like shooting a free throw in basketball. Well, if you shoot one free throw and you make it, well, then you were accurate. But were you precise? You have no clue whether or not you're precise, because precision requires repeated efforts and consistently getting them right. So, or consistently kind of landing in the same space. So our best answer option for this is B, precision cannot, or it is false to say that precision can be assessed after a single trial. Multiple trials are required in order to assess whether or not someone was precise in an effort. I'm going to go ahead and stop right there. And on your next video, I'll go through the next group of questions. Have a good one.